Okay, so try pi over 4. How would you get pi over 4?
180 divided by 4.
Good, that's a good strategy. So again, if you're thinking about the unit circle where it comes from, back to basics, there's 180, and I need 4 of them. So 1, 2, 3, 4. That means if the whole way around is 180, then I have 180 divided by 4, which is how many? 45 degrees. Good. Okay. And last one, can you do it without a unit circle? Good, 30 degrees. So let's try and find what's the formula going to be here now when we look at the other conversion. Okay, so it's the same thing that we had before, right? 360 degrees is 2 pi. So how do we get 1 radian into degrees? Over pi, yeah. We just have to divide 2 pi out of the equation. So divide both sides by 2 pi. And that means I've got 180 degrees. 180 over pi will get me back into radians. So what you'll notice between this conversion and the other conversion here is that both of them have the same numbers. So the key ratio that you want to remember is this pi over 180. And 180 over pi. So what I remember is radians are the unit circle. They have pi in them because they have circumference in them, right? Around the distance around the circle. So when I want to put pi into my answer, that means I need to multiply by pi. So this is to go from degrees to radians. However, when I want to get out of radians, I want to get back into degrees. Radians get back into degrees. That means I need to divide pi out of my answer. So by dividing pi, you're going to see them cancel. So that's how I remember. If I want to go from degrees to radians, I want to add pi, pi goes on top. If I want to go from radians to degrees, I need to remove pi, pi goes on the bottom. So here's what I mean. Don't follow my explanation. Pi over 4, I want to get into degrees. I want to get out of pi. I want to remove this. So pi goes on the bottom to cancel them, which means 180 is on the top. 180 divided by 4 is 45 degrees. Okay? So that's how I remember if it goes on top or bottom. Okay, so would 7 pi over 3 be if we were to convert this to degrees? Sorry, negative 7 pi over 3. Just getting really hot in the classroom now. Actually, before you want to open that extra window there, Ming, before we do start to get really hot. So what do you think?
Negative 420 degrees.
Okay, well let's verify. Where does pi go on this top or bottom? You want to put it on the bottom, so it's going to be 180 over pi, because that way I'm going to remove pi from my work. This number can go in my calculator, 7 times 180 divided by 3. So I'm going to have negative 420 degrees. Okay? Now these ones, we're not going to be able, because we don't have fractions, we're going to end up having to round our answers. So let's just do one of them. It may be that you have to round an answer if you're doing this. 5.2 radians, if I'm to multiply that, is going to be same idea. I want to get into degrees, so it's going to be times 180 over pi. So I get, it's about 298 degrees. Okay? Okay, so your calculator can deal with radians. So be careful, because now that I'm showing you this, you got to make sure you work in the right mode. So for example, if you lend your calculator to a friend, make sure you tell them, because if they write a test, they may end up getting the wrong answers. For example, if we want to work in radians like it is here, then all we have to do is change the mode in the calculator. So I can come around and show you on yours, But basically, you usually end up getting like an R in your screen, or maybe because, you know, math is awesome, you get rad. So in mode, I'm going to change mine to radian. Now I can evaluate this directly. I don't have to do the conversion. Okay, I can just put it in my calculator. It'll do the sine of 7 pi over 6 for me. Okay, so 7 pi over 6, put it in your calculator and see what answer you get, and we'll double check and make sure you have the right mode and everything happening in yours. So yes, you should get negative 0.5 if you put this in one right. Okay, let's just try one more. We don't need to keep punching it in the calculator, but let's try cosine of pi in your calculator. What do you get for the cosine of pi? Yeah, -1. Okay, so be careful though. Now that you have two modes, you have to make sure if the question is in degrees, you need to be in degrees. If the question is in radians, you need to be in radians. Okay. So here's our first really important idea. The radians is important, but obviously it's just a conversion. It's like going from miles to kilometers, okay, pounds to kilograms. So here is the first sort of concept that you have to think about, and that's going to be we're going to do the unit circle. We're going to put it on a graph. Okay. So here's the circle that we just were looking at, which has a radius of length 1. We're going to stick it onto a graph, centered at the origin. Now what we're going to do is, if this is the point x and y, we're going to try to figure out how we can connect these things up to trigonometry and using this unit circle, how we can try to link them. So first of all, we're dealing with trigonometry. We need an angle in here. So the angle that we're going to deal with is going to be this angle in here. And the triangle that we're using is the triangle, the other two sides are red, but that's the triangle. So what I'm going to try to do now is show you how we can take the triangle and apply it on the unit circle, and some trig pops out at us. Okay, so can anybody come up with an expression for the sine of theta? Okay, so this is the angle theta. What would the sine of theta be equal to? It's easy when there's numbers, right? But look at this picture. Can we put any numbers on this? Maybe? Can we label anything? What do you want to label, Jackie?
The sides.
The sides? Okay, how do you want to label the sides?
Just like labels.
Which letters?
I don't know.
There's two important ones already up there. X and Y. So which side is X? Which side is Y? The bottom is X, and again, it's weird because we're working with letters, right? We don't have a number, but this length, if that's the coordinate XY right here, then this length must be the length X, okay? So the other one, if I'm this tall, that coordinate is Y, this must be also Y. Can you label the last side of the triangle? 1, yeah, it's the radius, so the last side is 1. Okay, now let me ask you again. Can somebody tell me what the sine of theta equals? Y over 1. Okay, so sine of theta is the opposite over the hypotenuse. So that's going to be y over 1. So it's just the y coordinate. Okay, how about, let's write an expression for the cosine of theta. X over 1, which is just x. How about the tangent of theta? Yeah, it's going to be y opposite over adjacent, y over x. Can anybody come up with another way we could describe that? Y over x? How else could we explain the tangent? Oh wow, genius. Do you see that? If the tangent is y over x, y equals the sine of theta, x equals the cosine of theta, this is the same thing as the sine of theta over the cosine of theta. So really in trigonometry, we only need to worry about two ratios. The tangent is the sine over cosine. You can verify that by trying some values in your calculator. but the sine of an angle is the tangent of a theta is the same as the sine of the angle divided by the cosine of the angle.